All right, time for Triangle Congruence Day 2. So your learning goals for this lesson are: I can use triangle rules to prove two triangles congruent, and use the midline theorem to determine information required to solve application problems. So let's look at our first example. So we're really just building on what we did yesterday, except now you have to supply everything. It's not fill in the blank. So we're given that AB is congruent to CD, so always mark your diagrams. AB and CD are congruent, so make your marks there. And that angle DCA is congruent to angle BAC. And we need to prove that triangle DAC is congruent to angle BCA. So start off with your statement. Now notice today I put them both in one just so you could see what that would look like. And the reason is that's given. So we have AB is congruent to CD and angle DCA is congruent to angle BAC. So right off the bat, before you go to anything, we know we're trying to prove triangles congruent. So we need to think about, how can I do this with the given information I have? So I've got a side and an angle in both already, which means it's either going to be angle side angle or side angle side. Those are the only two that have angles and sides. Or we could do angle angle side, but we need to figure out which one's best. So do we have any way to do angle side angle? Do we know anything about angle D and angle B? Not enough to do anything with this, so that's a no. All right. So, and then we also have angle DAC and angle BCA if we wanted to do angle angle side, but we run into the same problem there. So that only leaves side angle side. And we can do something with that because if you notice, we have a shared side between the two triangles. So we can say that AC is congruent to CA, and that's by the reflexive property. So that'll give us that. And now we have side angle side. So we're done already. So we know that, oops, we don't need that step there. So this step is unnecessary. I don't know how that snuck in there. So we really only have 3 steps, and we've proven that triangle DAC is congruent to angle BCA, and that's by side angle side. Now let's get into the midline theorem. Definition: so midline theorem, or the midline of a triangle, is a segment joining the midpoints of two sides. So if I have a triangle and I have a midpoint here and a midpoint here, midpoint's the point exactly in between the ends, and I join those two, that would be the midline right there. All right. Properties of the midline is, again, that it joins those two and it's parallel to the third side. And the midline joins in midpoints, and this line right here, this midline, is half the length of this one. So if this was A, that would be 2A. Okay, if this was X, then if this line down here was X, then this would be 1/2 X. So let's put it into use. Using the diagram below, we need to determine the distance across the lake AB. So this is our lake here. We need to determine this distance here. We need to also justify which is a shorter distance, from A to B or from B to C. Now, I'm told that this side is 10 miles. I also know that this and this are equal. They're congruent. So that means that if the entire length is 10, then each side would be 5. So I don't know if you'll be able to see that on there, but if we take two congruent parts and we add them together, that's going to give us a 10. To find the length of AB, we're going to name this D, and we're going to name this one E. So AB is half the length of DE. We know that DE is 15, so therefore AB is 7.5 miles, because it's half that distance. And then that answers the first part. For the second part, we need to justify which is shorter. Well, that's easy now. B to C is shorter because 5 miles is less than 7.5 miles. And like I said, nice short video. That's it. One more target left in this key concept, and then we're done with this unit. So, yeah, that's it. Again, take good notes. Anything you do not understand, please ask questions.